Good morning, everybody. So, in previous lectures, we have understand about the how to analyze the compression member and particularly struts. In that case, we have understand that how to find out the design compressive strength, that is PD, using IS 800 2007. In that case, we have taken different cases: single equal angle, single unequal angle, double angle, either side on gusset plate, same side on gusset plate. Each kind of example we have studied. Now we are going to design the strut as a compression member. So what is the basic difference between design and analysis? So in analysis we have member, and after that we have to find out the design strength. But in design we have only a force. This much compressive force is acting on these struts. From that we have to first finding out the which member is suitable over here, and how we can calculate that, how we can judge that member. So for that we have just basic steps for finding out the member which is used for taking given compressive force as a strut. And after that we have to analyze that if we have used this section, it is capable to take given compressive load or not. If it is okay, then our design is okay. So for the detailed understanding, here I have taken one example, that is design a single angle discontinuous strut to carry out the factored load of 65 kilonewton. Assume that the distance between its joint is 2.5 meter. Use Fy 250. So here we have one clue of member, that is we have to select single angle, and the given factor load, that is 65 kilonewton. So P is equal to 65 kilonewton, which is factored. Effective length, for any case we have to take effective length, that is KL, and center to center length of the member, that is 2.5 meter. So it is 2500 mm. Now for the analysis and design we have take slenderness ratio, that is KL upon R. It is most important thing. So here we have no member. So we have to first assume that KL upon R, that is 120 for a single angle, and if it is double angle then it is 100. So here KL upon R is equal to 120. Now FCD, Using this KL upon R from page number 42 in IS 800 2007, we can finding out the FCD. That FCD is equal to 83.7 Newton per mm square, because 42 number page is for the C class and our single angle is lies in C class. Now we have equation that is given on page number 34, that is P is equal to A into FCD. We have to make masters of that A as AG, and AG is equal to P upon FCD. Now we have this P. So here required area we will get, that is 777 mm square. Now from this area we have to choose a single angle section from the steel table. In that case we have to take three properties of that section, that is area which is greater than this one, B upon D, T upon D. This is the our section selection, and KL upon R which is less than 180. If this is satisfied, then our selected section is okay. Now we have taken ISA 75 by 75 by 6 mm from steel table, and area of this section, that is 866 mm square, which is greater than this one, that is our section is okay in area. Now R minimum for this section, that is 14.6 mm. So KL upon R for this, that is 2500 upon 14 point, which is 171.23, is less than 180, then it is okay in slenderness. This KL upon R value, maximum value of KL upon R, that is 180, is given on page number 20 IS 800 2007. Now after finding out the section, means selection of section, we have to again analyze that section, and for that first we have to select our classification. So it is B upon T, D upon T, and B plus D upon T. If these three conditions are satisfied, then our AG is equal to A, and that is 866 mm square. Now whenever we are going to design a section, we just assume that our applied load is eccentric. Always we have to assume this. So for that we have to assume two bolts at each end and fixed condition. For that we have K1, K2 and K3, which is given on page number 48. Now after K1, K2, K3, we have to take lambda VV and lambda phi, and it is already calculated previously number of times. So we will get lambda E from that section. So after getting lambda, we have to take alpha, and alpha it is 0.49 for a class C, that is given on page number 35 IS 800. So alpha and lambda will gives us the phi, and we have the equation for the phi, right? So we will get phi is equal to 1.735. So from this stress reduction factor, x is equal to 1 upon 5 plus alpha minus lambda square raised to 0.5. So we, after putting the all value, we will get x is equal to 0.358. Now put up this value in our equation of FCD, that is given on page number 34. So we will get FCD, that is 81.36, and our AE we have, so we will finding out the design compressive strength. PD is equal to AE into FCD. So it is 70.46, which is greater than given load. So our design is safe for the section. Now here again another example, that is design a double angle discontinuous truss. Here we have to take double angle. Carry a factored load of 200 kilonewton. The length of the strut is 3 meter between the intersection. The two angles are connected back to back on opposite side of gusset plate and tack bolted. Assume the grade Fe415 and Fy250. So P is equal to 200 kilonewton and it is factored. We have to assume KL upon R as 100 for double angle. So FCD is equal to 107 megapascal from page number 42, as we know. Now required area, that is P upon FCD. So here required area, that is 1869.15 mm square for a 2 ISA, because here we have to take double angle. So from this steel table, the double angle strut and the area for that, that is 1910 mm square. R minimum for that, that is 26.25 mm. So from here we will get all the data from steel table. So effective length must be calculated on the basis of IS 800, and K is equal to 0.85 for a double angle. We will know that. So KL is equal to 2550 mm. Now KL upon R, that is 97, which is less than 180, that we know, given on page number 20 IS 800 2007. Now design compressive stress, that is KL upon R is equal to 97.14. So FCD is equal to 111, which is coming from the page number 40, as we know. Now design compressive strength, PD is equal to A into FCD. Put all the value, so we will get PD is equal to 212 kilonewton, which is greater than 200 kilonewton. Now our section is safe. So provide 2 ISA 100 by 65 by 6 mm on both sides of the gusset plate. Clear? So always in a design we have to just take the consideration that first we have to assume KL upon R, and after that finding out the required AG. After getting AG from steel table, we will finalize the section, and after that just check that our section is capable for the given load or not, and if it is safe, then it is okay. Otherwise, revise the section and select a bigger section from the steel table, so it is automatically okay. Now कॉलम, अभी तक हमने स्ट्रट्स की ही बात की, एनालिसिस ऑफ स्ट्रट, डिजाइन ऑफ स्ट्रट. नाउ वी आर गोइंग टू टॉक अबाउट द कॉलम. What is column? We know that in structural analysis 1 we have studied that a column is having I section, it is pure vertical, having bigger cross section, right? That's why we are going to call it is a column. So here in column we have always I section, whether it is IH, HB, IS, WB, IS, MB, IS, LB, IS, HB, whatever. But the calculation process is a little bit different as compared to struts, because here the given I section is different for the section classification, and that section classification is given on page number 18. So all of you just open the page number 18 from steel table, and sorry, IS 800, just parallelly open the steel table and open this section, that is ISLB 300 at the rate 37.7 kg per meter. With reference to this weight, we have to take the all parameters from the steel table. What here we have to just classify our section whether it is okay or not. So for the section classification, we have to just refer a page 18 from IS 800 2007 and 19. We have to refer both the page. In that case, we have to take the dimensions of the I section ISLB 300, which is given in steel table. So all of you just open these two pages, page number 18, 19, and just steel table on the page where it is given. Do it. Hope you have opened. Now on page number 18, for the compression member and the neutral axis at the mid for the section. For that, we have some criteria, and that criteria which is given on 18 and page number 19. Whenever we have this kind of section, that is, this is our total H, this is width of flange, this is thickness of flange, this is thickness of web, and small b is equal to half of width of flange, and d is equal to here only. Clear? Now for ISLB 300, BF is equal to 150, B is equal to 75, half of this, thickness of flange we have, thickness of wave we have, R and H, all the detail given in the steel table. Now epsilon that we know, which is given on page number 18, IS 800 2007, not number 2, and epsilon that is 1. For section classification, here we have to classify our section for flange and for web differently. So here B upon TF, that is 7.978, which is less than 9.4. So our flange is in plastic. But what about the web? For the web, it is D upon TW, and D it is calculated from the total height minus 2 times of thickness of flange minus 2 times of root radius divided by thickness of web. So we will get 37.49, which is less than 42 epsilon. So it is semi-compact. So our whole section lies in a semi-compact. Clear? So it is very much simple. Now we have another section, that is ISHB 400, and for that section we have different criteria parameters. Width of flange, that is 250, width is equal to 125, half of this, thickness of flange, thickness of web, root radius, height, all things we have in steel table. Now again, for the flange B upon TF, that is 9.84, which is less than 10.5, so it is compact. Web, d upon dw, and equation that we have, that is 38.52, it is 42 epsilon. So web is in semi-compact. So our whole section is semi-compact. Now, dear students, this is the just first step of our column, that is how to classify that column. In strut, that is very much simple, but now in a column it is very much difficult. In column, there is, we have two, long column, short column, classification of section, FCD, all the things are calculated as per the criteria, different criteria. So it is very much difficult to understand, but they all things we will discuss in our next lecture. Till then, thank you very much.